All right, so everybody doing well? So what we're going to do is I'm going to open the book, and we're going to go to a page. Are you guys getting pretty good at net ionic equation? You want to try one more of those or not? Let's try one more. I'm going to go to the back of the chapter. Let's take a look at what's the one that has net ionic equations? Okay, let's go to question 25, 25C. 25C. All right, so I'll show you the question, and I'll give away some of the questions that are on the test. Let me magnify this for you. C. There we go. All right. Now, some of the questions will say, write out the net ionic equation. That's what we're going to do. But I'll show you another series of questions we have. And let's say something like this. For the following reactions, if a precipitate forms, write out the formula of the precipitate. Okay? And it'll be 6 in a row. And all you do is you sit there, and you don't need to write anything out. If you do this the right way, he said it's double replacement. I know what the products are. I can look them both up, and one of them is going to be a precipitate. If it is, I write the formula of a precipitate. But what if both of the products are aqueous? What does that mean? What if both products are aqueous? Then there was no precipitate. You write none. There was none. So let's go ahead and do this question. We'll go ahead and do the net ionic equation for this guy. It says here 25C. Let's do 25C, ready? Now, we know that these are double replacement reactions. It tells them they're aqueous to begin with. So let's take a look. Tell me who's not 100% sure about net ionic equation. All right? So it's going to help you. Okay? Just trust me, okay? It's going to help you. It's double replacement. All I ask you to do is tell me the names of the two products. So switch the guys around. See, switch the plus and minus in there. What do you think? What are the two products going to be? Ammonium what? Yes, and what's the other one? You're exactly right. Now, I haven't written down anything, have I? So we're going to look those up. Let's look those up on our chart. Where's my chart? I lost it. I'll say it again. He said ammonium chloride, right? And maybe, to save a little time, maybe you'll remember that all ammoniums were what? All ammoniums are soluble. And if you don't remember it, I'll give you the chart. Everybody get it? So now, we don't need, that's not going to be precipitate, is it? All right, what's the other product? You said what? Calcium what?
Phosphate.
Let's try that. Now look up calcium phosphate. And, ooh, solid. Okay, so I'm ready. I'm ready to do it. Man, clear my throat. All right, let's try it. I'm magnified, aren't I? There we go. Tell me again, calcium what?
Ammonium.
I know, but the two products are calcium phosphate, wasn't it?
Yeah.
Okay, now how do you write calcium phosphate? It's true, if you still don't know how to write formulas, you're going to get hurt a little bit. So how do you write? Do you know how to write calcium phosphate? As a matter of fact, you were actually pretty good at writing formulas. I remember that. So calcium's plus 2, right? Phosphate's minus 3, so you put a 3 here and a what? 2 here? On the questions it says, if a precipitate forms, write the formula for the precipitate, you're done. You're done. You get it? But this one says to write the net ionic equation, so I'll put an S here. There's my driving. That's a solid, right? Now, we're going to go backwards. This is going to seem weird, isn't it? Let me ask you this. What's the only way that this ionic compound could have formed? I'm back to Kayla now. Kayla, what is the only way this ionic compound could have formed?
Like calcium and phosphate.
Say it again.
Like combining calcium and phosphate.
Calcium, what form of calcium? Starts with I. Ion. Isn't that right? And calcium, look on the periodic table, it's plus 2 ions, right? And Kayla, were these dissolved in water? You know what the name of the chapter is? Reactions in an aqueous solution. Are these dissolved in water? Oh, yes. So we've got calcium ions, and they're going to bump into who?
Phosphate.
What form of phosphate? Is it an ion? Is it an ion? Is it dissolved in water?
Yes.
All right, are you done?
Do you need to balance it?
Yeah, something wrong, isn't it? This is not a real chemical equation. This is a net ionic equation, right? So I wouldn't use the word balance, but I would say balance, yeah. But take a look at this. Can you take one of those and add it to one of those and get that? Can you take one of those and make that? No way. So now, I had to fix this. What am I going to do here?
You need 2 phosphates.
How many?
2
Yes.
and 3 calcium.
How many calciums?
3.
Does that make sense now? So 3 calcium ions would bump into 2 phosphate ions and make this guy here, wouldn't it? All right, does that make sense? So say on Friday on the test, it'll say, if a precipitate forms, write down the formula of precipitate. That's all you write down. That's all you write down for that question. But if it says, write out the net ionic equation, then I write this, don't I? Now, is there going to be a time where I make you write out the whole balanced equation with the AQ and yes? And we'll have one time where I make you write out the complete ionic equation? Yes, one time. And then I'll make you write that. See, I'll make you do that. But all the other times, there are multiple choice questions. Don't take that much time. Did you see me balance the original equation here? I didn't. I didn't balance the original one. I didn't write out the complete ionic. That's why the shortcut is what you want. So if you want the net ionic equation, that's it. All right, well, real quickly, how about D? Look at letter D. How fast can you do that one? Ready? Try it. Letter D. I'm not writing anything down. I'm not writing right now. There's nothing to write down yet. Not yet. Hydrofluoric acid. Potassium sulfate. Switchy. And what are the 2 products going to be? What are the 2 products going to be? John, what do you think? What are the 2 products going to be, John?
Potassium fluoride.
Yeah. Wait, potassium fluoride, right?
Yeah.
Potassium is plus 1. That's one of them. What's another one? It says hydrofluoric acid. Wait, hydrogen what? Hydrogen sulfate. Uh-oh. I need 2 of those, right? Right? Those are the 2 products. What do you think? What do you think? Either one of those going to be a precipitate? Either one of them going to be a solid? You can look it up. And some of you on the test, here's what's going to happen on the test. I know what's going to happen. Somebody's going to go like this. You're going to look on potassium, and you're not going to see fluoride up there. Fluoride's not up there. What are you going to do if fluoride's not up there? What are you going to do? First of all, if it's not up here, you check down here, don't you? Don't you check down here? Okay, so what's it say? Alkali metals. Okay, potassium and sodium, all the salts are soluble, aren't they? You can't be a precipitate. So, no way. You're out of here. What about the other one? H2SO4. That rings a bell. What is that? What is H2? Let's see if Danielle knows. Danielle, what's H2SO4? It could be, but it's in a solution, so we call it sulfuric acid. Isn't it an acid? All acids are solutions. All of them. Got it? So what are you going to do now? Both your products are soluble. What does that mean? NR. That's right. NR. Okay. See that? This? And no reaction. But last chapter, if you write it down, it means it happened. Not this chapter. This chapter, we have to figure out if it's going to happen. All right, you okay on that? All right, and the other thing, I don't want to spend too much time on acid base, but where am I? Acid base. All right, we did this the other day. Okay, there are two kinds of double replacements, right? One of them is the precipitation reaction, and that means that the reason it occurred is the formation of a solid. We just got doing a bunch of it, didn't we? Precipitate, use the chart. That's the only time I use that chart. That's the only time I use it. And then the other kind of double replacement is acid-base neutralization. And I'll tell you, if you take any acid and any base and you add them together, you're going to get water and a salt. It just so happens, it's a coincidence, that's the most famous salt here, okay? Any ionic compound is a salt. So anyway, you build the complete ionic equation, and then you cross out the spectator ions, and what do you always get? What do you always get when you have acid-base neutralization? The net ionic equation is hydrogen ions from the acid bump into, what are these called? Hydroxide ions in the base and make what? Water. Water's not an acid or a base. It's neutral. No wonder they call it acid-base neutralization. The net ionic equation tells you that if you have the same number of these as these, everything will be water. You can even drink it. What? Yeah, if I did it carefully, I had just the right amount of acid to just the right amount of base, everything in there would be, it wouldn't be an acid or base anymore. It'd just be water. All right, so I'm not going to spend a whole lot of time on acid-base, but it's a double replacement reaction. Formation of water is the driving force. All right, now, what I'm going to do is get to the part that I need to help you with, okay? I need to help you with this part. It starts right about here. And it says reactions of metals and nonmetals, oxidation, reduction. All right, so here we go. This is today's lesson. I've written this out so many times. Okay. Well, let me start over. Let's start over. Okay, so far, here's what you know. Double replacements, there are two kinds, right? What are they? What are the two kinds of double replacement? All right, precipitation. And that means the formation of a solid, right? And what's the other one?
Acid-base neutralization.
Very good. And that's the formation of new water. I'm going to draw a line there, okay? All of the rest of them that you ever learned, single replacement, synthesis, decomposition, combustion, even though we can classify them this way, you can also classify double replacement as being this or that. You get that? You can also say that every one of these has the same driving force. The transfer of electrons. All right, you okay with that? That's not scary. Why do these other reactions take place? Is it the formation of solid? The formation of water? What makes them happen? Somebody's going to lose electrons and somebody's going to gain. Well, what about up here? No. Nobody loses electrons up here. Nobody gains electrons up here. No. Here they do. So they have these fancy words, okay? They have these fancy words. If you were to lose electrons, if you lose electrons, they say you got oxidized or oxidation took place. Now, how do I've seen different memory tricks on this. This is the one I use. And it just so happens that last year's valedictorian went to NC State and did really, really well in chemistry. And he says, I'm even teaching people some of the tricks you have, like Leo says grr. He wrote that in a letter to me. Remember Leo says grr. Leo the lion says grr. So Leo the lion says grr. If you remember Leo says grr, you can remember the loss or losing electrons means oxidation. And what's the other one? If you gain electrons, then what? Anybody know that word? Everybody did any reading? Reduced or reduction. So here's your two new vocabulary words, oxidation, reduction. And as a matter of fact, what do they call these four kinds? They're called oxidation, reduction reactions. I was telling some people at lunch, the chemists really are humans. You don't think they are, but they're humans, and they have families, they have fun, and they just enjoy the puzzle nature of science. They enjoy discovering things. They enjoy anyway. I don't know what day they sat around and saying, "Hey, aren't you tired of saying oxidation reduction reactions, oxidation reduction?" And I don't know who did it. They probably, you know how you said brunch? Who thought of that? It's kind of between breakfast and lunch. And somebody said brunch. I like that. And I know you've probably tried to figure out a nice word for something in between, like lunch and dinner. What do you call that? It just doesn't. I haven't come up with a good one. Have you come up with a good one yet? Dinner, no. Lunchner, no. Anyway, it just doesn't happen. But in this case, they said, we have another way, a shorter way of saying the same thing. And what is it? If you read it, you know. Redox. Now, I told somebody at lunch, I said, even though, I understand my school, when I went to school, it was at a certain level. We didn't have honors classes or non-honor. We didn't have that. And so I get it. But I went to college, and my first semester in biology, they were talking about how many reactions in biology were redox. I had never heard that word, ever. And then in chemistry, redox. They kept hitting me with that word. I didn't know what it was. Well, all it means is that it's a reaction where somebody gains electrons because somebody lost them. You see that? And you have to take place simultaneously. They have to. I'm not losing my electrons unless what? Unless you're there to gain them. I don't just go around losing my electrons. And so what I'm going to do is I'm going to show you a little way how to figure this out. Who got oxidized and who got reduced, okay? I'm going to show you one more little trick here with Leo says grr. All right, think about this. If you were to lose negative electrons, if you lost negative electrons, you would get what? If you lost negative electrons, you would get more what? Wouldn't you become more positive? Isn't that right? What do metals do when they lose electrons? Don't they become positively charged? Cations? Look at this now. What if you gain negative electrons? What if you gain negative electrons? You were neutral, and you gain some extra electrons. What happens to you? Don't you get more what? Don't you get more negative? Don't you or not? Can you remember that? Now, we're going to do this over and over, and you'll say, I think I caught on this. You won't catch on right away. I'm all right. You won't catch on right away. All right. I will prove to you that synthesis reactions are redox. Are you ready? I'm going to take the simplest synthesis I know of. If you take sodium metal, and that means solid, and if you were to add it to chlorine gas. You would not have to heat that. It will violently react, violently. You'll see a flash of light. Heat will be given off. And on the inside of your container, you'll see little crystals of table salt. Everybody see that? Now, you don't know that. I'm telling you that. But is this a synthesis reaction? A plus B is synthesis, right? Isn't it? A plus B is AB? Is it balanced? No, it's not. Okay, so we have to balance the equation. Let's do that. Oh, you see. All right. Is everybody ready? Now I can show you how this is redox, okay? Now what I'm going to do is we're going to do these things that your book does not have this in here. I'm going to teach this to you, okay? They're called half reactions. Now, why are they called half reactions? Because they tell half of the story. So I think I will do the Leo half reaction. Let's do the Leo half reaction. What does that mean? Tell me the story of who loses electrons and becomes oxidized. I'm looking at your faces. It's okay if you don't get this right away. You're okay. Now, in the book, it says, it gives you some rules, general rules. It says that any element that is not combined with another element has an oxidation state of 0. I never said the sodium was +1. I said sodium was always +1 in a compound, didn't I? Sodium metal is not +1. Sodium metal is 0. It's not an ion. Now, so any element not combined with another element has an oxidation state of 0. This guy is not combined with a different element. He also is 0. But take a look over here. What is, and if you're an ionic compound, your oxidation state is your charge. So what is the charge of sodium in a compound? And look at your faces. Everybody should know. +1. And what about chlorine in a compound? Now, I want you to look. True or false? Did somebody change their charge? Then it's redox. Matter of fact, on the test, here's what I do. Hey, are you double replacement? No. Then you're redox. When are you not redox? When are you double replacement? All these. Somebody's going to change their charge. Matter of fact, 2 things have to change their charge. So let's take a look. Ready? Let's find Leo. Who lost electrons and became more positive? Can I give you a little hint? I'll give you a little hint. Number line. Remember the number line in math? I'll give you a hint. If you go this way, you became more positive. If you go this way, you became... All right, let's try it. Ready? Anybody find it? Tyler, what do you think? Who got oxidized? Who became more positive? Yes. Sodium went from 0 to what? Whoop! +1. Now, I'm going to show you how I do it, okay? If you go to college, you learn a little, I'm okay with that. This is the way I do for first-year chemistry, and even my second-year chemistry, I do it with it, and they like it. Start out with 1 atom at a time, okay? Sodium, who started out as 0, turns into what? Sodium, who started as sodium metal, turned into what? No, let's take a look. Oh, he turned into a sodium ion. Yeah, sodium ion. How do you do that? How do you go from here to here? I had to give away an electron. Now, I know what some of you want to do. You want to say sodium minus an electron equals sodium plus 1, but they don't do that in chemistry because it's a product. This produced this and this. That's why I have to put on Leo, when you do the Leo story, put the electrons over here. You get that? Because they're going to be produced. Now, are you okay with that? I'm going to do another one. Who got reduced? Let's tell the Gur story. let's pick, I don't know, Elizabeth, you can do it. Elizabeth, tell me the Gurr story. Who gained electrons and got reduced? That means they got more negative. Yes. And we're going to do one atom at a time, okay? Each chlorine started as what? 0. Now leave a space here. Leave a space here, okay? And became, yes. Now, tell me, how is that possible? How can you start at 0 and turn into something that's -1? Yes. Yes. I'm going to cry. This is great. Now, when you had to gain an electron, I had to put it on the left side because this has to react with this to form that, doesn't it? Now, there is a problem, though. I do have a problem. The problem I have is we almost have the story right. This said that you only started with 1 sodium atom. Is that true? No, that's not true. But here's how I started. I started as 1 atom at a time. Then I go back and fix the numbers. You get that? Can you at least understand this? Sodium can turn into this by giving away an electron. Can you understand that? Can you understand that chlorine, if you tack on another negative electron, it's going to become chlorine -1? If you can understand that, then the number part's not too hard. Let's go back. I didn't start with 1 sodium. I started with what? 2. So I put a 2 there, right? And I didn't end up with 1 sodium ion. I ended up with what? 2. But you told me each sodium had to lose 1 electron, but now you're telling me you have 2 sodiums? So how many electrons were lost? 2. Are you okay with that? I'm looking at you. We're going to do this more than once. You get it? We're going to do it 3 times a day. You say, by the 3rd time, you said, okay, by the 3rd time, I'm going to get this. Now, let's fix the numbers on the this guy. This said you started with 1 chlorine, did you? No. Now, what form? You didn't start with 2 chlorine atoms. You started with a diatomic chlorine, didn't you? So I had to put that there. See, that's right there. It's right there. And you didn't end up with a 1 chlorine ion. You ended up with what? 2. But you told me that each chlorine had to gain 1 electron, but you had 2 chlorines now. So what are you going to put here? Yes? And here's what you want to check, okay? Can I show you something? See this right here? This has to match. Why did it have to match? What do you think? Anybody feel smart today? Elizabeth, she did a good job. Anybody feel smart? Why do they have to match? I'll give you an analogy. Can I give you an analogy? Here's a question I always ask on the test. How many total electrons were transferred in this reaction? Write down your answer. Don't say it, just write down your answer. How many total electrons were transferred? Okay, Max, come up here just for a second. Just stand up here. I'm going to show you a little thing here. These are not real dollars, but they're in my, in physics, there's this thing called density detective, and they use this for snitch cash. I'm going to lose $2. Okay? And how many dollars did he gain? How many total dollars were transferred? I bet you wrote 4 in your paper. If you wrote 2, you're pretty smart. Because it's the same 2, isn't it? Isn't that right? If I lose 2 electrons and you gain 2 electrons, how many total electrons were transferred? 2. And so guess what? Nobody in chemistry is going to lose 2 electrons unless somebody else is there going to gain how many? 2. Nobody loses 4 electrons and have somebody only pick up 1. It never happens. It always happens identically, simultaneously, as a redox. Redox. Okay, well, let's assume that you understood a third of what I said. How about that? Let's do it again. I'll do another one. And you said, ooh, I'm up to 70% now. Are you ready? I will prove to you that, let's see, which one can I do now? I will prove to you that a single replacement reaction is redox. All right, here's one you will do in the lab. Here's one you're going to do in the lab. If you take zinc metal and you put it with hydrochloric acid in a single replacement reaction, does everybody know what's going to form here? You always may be very proud. This class is very high level. You're doing a great job so far. You got that? You have, I think your class average was something like 89. Whoa! The average? That's way up there. So you're very close to getting an A average for the whole class. So therefore, you should be able to tell me what I'm serious. Try it. Write it down. It's okay if you make a mistake. Single replacement. Whoa, what's going to happen here? We did this last chapter, didn't we? Everybody got it? Did you balance it? All right, single replacement. Zinc is going to become a zinc ion and kick this guy out. So when you kick hydrogen out, am I going to write H? Or am I going to remember that by itself, hydrogen is a diatomic element, isn't it? Matter of fact, when you do this experiment, you'll get thousands of little tiny bubbles, thousands of little tiny bubbles coming off, and you're going to test those for hydrogen. They'll explode. Well, I say get them to explode inside the test tube, okay? And so hydrogen gas is going to be produced, but what's the other product? Ethan, you know. Show off, okay?
Zinc chloride.
Zinc chloride. How do you write zinc chloride? Zinc's an always metal. You know what? Because I didn't hear a Roman numeral.
Yeah, it would just be 2 chloride.
That's right. That's right. Very good. Now, hey, do you know what? If you were to look this up, and we don't use that chart, but if you were to look it up, did you know that this is actually soluble? So you won't even see it. You won't even see the zinc chloride. Now, I'm not asking you to do that here, but that's not my point today. But now, let's do the half reactions, and let's do the Leo story. Let's do the Gur half story. All right, and what we do is, before we start that, we go up here and assign oxidation states. You get that? We're going to assign oxidation numbers to everybody. All right, first of all, when an element's by itself, not combined with anybody else, what are you going to tag him with? What number? 0. Anybody else going to be a big 0? There's a 0. Might as well get all the zeros out of the way. If you're an ionic compound, you take on the same oxidation number as your charge. I'm going to leave you as +2, leave you as -1. What about here? You got it, Noah? What do you think? Say it again. Yes, yes, yes. Feeling good about this? Okay, now, we didn't balance this. We have to balance it, don't we? Let's go balance it. Are you okay now? You have to balance the equation. Are you ready to go? All right, let's do the Leo story. Let's see, Ty, help me out. If you lose negative electrons, you become oxidized. If you lose negative electrons, you become more positive. Who became more positive? Say it again. Take a look. Zinc went from 0 to +2. You're right. You're right. So we're going to put zinc here. Now again, I'm going to do one atom at a time, and then I'll go back and fix the numbers, okay? Zinc started out as 0, and Leo, you always put the electrons on the right anyway. Ty, help me out. Zinc turned into what? Yes. And how can that happen? How can you go from 0 to +2? Excellent. Excellent. You're sounding great. You didn't even hesitate. That was great. you lose 2 electrons. You get it? Is that true? If you don't go from 0 all the way to +2, you got to lose 2 electrons, don't you? Okay. Let's do the GER story. You're doing such a good job. You keep going. You're on a roll. Now, if you gain the negative electrons and it get reduced, you're going to become more negative. Who became more negative? Okay. We're going to write 1 chlorine at a time. Chlorine started as what? Yes. We'll figure this out in a minute. What did he turn into? Oh. What happened there? Oops. What happened? Wait, you mean somebody, one of these 3 elements, was not involved in redox? Right. If he started as -1, he ends at -1, he's not involved in redox. So pick the other one. All right, we're going to start with 1, hydrogen as +1, and leave a little space. And what did he turn into? Hydrogen 0, yes. Now, how in the world can you go from +1 and drop down to 0? Gain 1 electron, right? Now, again, even though I do it with 1 element, 1 atom at a time, do you understand there's something not right here? You understand something's not right? Like, you lost 2 and I only gained 1. That can't happen. So let's go back and fix the numbers, all right? What do you think about these numbers here? Are you going to put any numbers here with zinc? No. What about this guy? No. And how many electrons is this? 2? Yeah, I'm sorry. Okay, now let's go down here. Are you going to leave that like that? 2 of them. There were 2 of them. But if each hydrogen had to gain 1, and you have 2 of them, then they must have gained 2, didn't they? And now, what are right here? This is the tough one. And what form? Coefficient 2 or subscript 2? Yeah, it really was diatomic hydrogen. See that? Now let's check. I lost 2. I gained 2. Hey, I think it works. Everybody get it? And by the way, for half reactions, we don't have the same rules. Like, you don't reduce half reactions, because they're only half the story, aren't they? They're only half the story. Wow. What do you think?
How many electrons would be transferred in that one?
2. This guy lost 2, and these people gained 1 apiece, or 2 total. They have to match. Well, if you understand this, you're in very good shape. How about we do another one? You want to do another one? You want to do another one without my help? If you can do one more without my help, I think we're in good shape. Let me think of a reaction. All right, let me think of one you can do here. Okay, we did synthesis, we did single replacement, and we know we're not doing double replacement. So let's do, how about decomposition? Let's do it. This is a single replacement. Let's do another single replacement. This is a good one. That's a good one. We're going to do another single replacement reaction. And what we're going to do is aluminum. Aluminum is going to react with rust, iron 2 oxide, and iron 3 oxide. And it's going to be a single replacement. All right, see if you can do that. See if you can finish it, balance it, and then tell the Leo half story and the GER half story. What now? Fe2, yes, I'm sorry. Fe2O3. All right, see if you can finish it. It's single replacement. This is kind of like last chapter. The first step is kind of like last chapter. Can you finish the equation? You have to balance it. All right. Is everybody, I bet you're not done yet. How about the first part? Is everybody get the first part done? Did you make aluminum kick iron out? And I hope it just so happens as a coincidence. It was a coincidence that it also comes out to be Al2O3. Okay? Is that right? Aluminum is +3. This iron is +3. Now let's balance it. 2. And 2. Is everybody okay on that? All right, so anyway, if you at least got this started, you probably could go ahead and do the Leo and the Girtons. So right now you're taking a chance. You said, I'm going to do this by myself, no help. If I make a mistake, I'm going to learn from it. Now we have 3 elements again. I wonder if all 3 are going to get involved, or only 2. Are you feeling okay? You have it done? Raise your hand if you have it done. That's pretty fast. Good. Man, that's really good. Again, this is the first day you've heard this. By the time you do some tomorrow, you're getting pretty good. You're going to be really good at this. All right, let's start. And, oh man, who call on? Davis. Davis, help me out here, okay? Did you assign oxidation states, everybody? That's step 1. After you balance the equation, you want to make sure you assign oxidation numbers, everybody, okay? Remember, if it's not combined with anything else, it's 0. There's another big fat 0. But here, this is +3, this is -2. Okay, you got that? Okay, now, Alex, let me ask, Davis, let me ask this question, sorry. If you lose negative electrons, they become oxidized. If you lose negative electrons, you become more positive. Who became more positive? Yes, that's great. Now, aluminum started at what oxidation state? And remember, Leo, you always write the electrons over here anyway. What did it turn into? How do you do that? How do you go from 0 to +3? What happened to you? Right, and you produced or lost 3 electrons. Get that? That sounds great to me. We'll fix the numbers later, okay? Who got GERD? Who got reduced? iron, okay. And what did it start out?
Iron 3,
Yeah. What did it turn into?
iron 0.
How do you do that? If you're a +3, how do you drop all the way down to 0?
Gain 3 electrons.
Yes. Now, we have you have the basic story correct, okay? Now we have to fix the number, so, Davis, what do you think? Are you gonna leave 1 here?
No, it's
2, okay. And, wait, if each aluminum had to lose 3, and now you have 2 aluminums, how many electrons are lost? You said each aluminum had to lose 3, but now you have 2 aluminums. So how many electrons are gonna be lost now? 6. Okay, and over here, what about that? You start with 2 aluminums, you only end up with 1? And it really did end with 2, didn't you? Now, I know what you're gonna think. This is this is what most people are making mistakes. I hate it. I know what you wanna write. You wanna write Al subscript 2. Don't do it. Have I ever talked about diatomic aluminum? Is aluminum by itself here? No. It's not even aluminum. That's aluminum oxide. What's aluminum oxide made of? Starts with I. Ions. There are 2 of those ions and 3 of those ions. There is no Al2. There's no Al2. It's not a diatomic element, and it's not by himself anyway. So I had to put 2 here. It's 2. 2 aluminum ions, isn't it? Okay, good job. Now, finish the story. Davis, go. Go back. You want to put subscript 2 or coefficient 2? What? Yes, because there's no diatomic element here. So it's 2 iron ions. But you said each iron ion had to gain 3, but now you got 2 of them. So how many are you going to gain? Now what over here? There we go. And again, we don't reduce half reactions because otherwise this would get out of whack, wouldn't it? Ooh, wait. You're one of the fastest classes I've ever seen catch on to this. Now, either you're shaking your head and you don't know what you're talking about, or you're shaking your head and you said, I think I know what I'm talking about. Wow. You're impressive. All right. We have time for, not much time. Is the decomposition of water a redox reaction? What do you think? If I put this on a test tomorrow or by Friday, how long should it take you to answer this? 2 seconds. Is the decomposition of water a redox reaction? Is it a double replacement? Then it's redox. Oh, that's how. Okay. What's the only ones that are not redox? Double replacement. How many double replacements are there? How many kinds? Precipitation and acid-base neutralization. Whoa. I'm starting to put this together. Well, thank you very much. You did a fantastic job today. Great job.